What if Earth stopped spinning? Imagine waking up one morning and the world feels almost the same. The sky is still above you. Gravity still holds your feet to the ground, nothing explodes, nothing shatters instantly. At first, it feels like nothing has changed at all. But then you notice something strange. The sun is no longer rising or setting the way it used to. Shadows do not move, time itself seems frozen in place, not on a clock, but in the sky. Earth has stopped spinning. For billions of years, our planet has been rotating without interruption, carrying oceans, air, cities, and people around its axis at enormous speed. We never feel it, never hear it, never see it, yet everything about life on Earth quietly depends on that motion. So what happens when something this fundamental suddenly disappears? If Earth stopped spinning instantly, the first effects would be violent and unforgiving. At the equator, the surface of the planet is moving at about 1,670 kilometers per hour. That speed does not vanish gently, it disappears all at once. The ground beneath us would stop, but the atmosphere and oceans would not. Air would continue moving eastward, becoming planet-wide shockwaves of wind faster than any hurricane ever recorded. Buildings would be flattened not by shaking ground, but by the atmosphere itself tearing across the surface. Oceans would surge eastward, not as single waves, but as global floods. Coastlines would be erased within hours. Entire ecosystems would be ripped from the land and swept across continents. Even solid ground would not be spared. Earth's crust, though rigid, is not immune to sudden changes in momentum. Massive earthquakes would fracture fault lines worldwide as the planet tried to absorb the loss of motion it has maintained since its formation. But suppose the impossible happened, suppose Earth did not stop instantly, suppose it slowed down gradually. In that version of events, the change would be quieter, but far more unsettling. Days would begin to stretch, a single sunrise could last hours, then days. Eventually, one side of the planet would face the sun for months at a time, while the other side would fall into months of darkness. Life would not collapse immediately, it would begin to bend. As rotation slows, the balance that shapes Earth's climate begins to unravel. The Coriolis effect, which helps drive wind patterns and ocean currents, would weaken. Weather systems that distribute heat and moisture around the globe would slow or disappear. On the sunlit side of the planet, temperatures would climb relentlessly, deserts would expand. Water would evaporate faster than it could return as rain. On the dark side, temperatures would plummet, ice would creep toward the equator. Entire regions would become uninhabitable, not because of sudden catastrophe, but because of prolonged extremes. Plants, which rely on regular cycles of light and darkness, would struggle to adapt. Some species might survive near the boundary between day and night, where conditions are less extreme, many would not. Migration patterns would collapse, food chains would fracture. Humans, bound to agriculture and infrastructure, would face a slow but relentless crisis of survival. Civilizations would cluster along the narrow twilight zone between scorching heat and permanent cold, reshaping societies around geography that never mattered before. Earth's rotation is not just responsible for day and night, it plays a central role in stabilizing the planet itself. As Earth spins, it bulges slightly at the equator. This shape helps stabilize its axis and moderates the distribution of mass across the planet. Without rotation, Earth would slowly become more spherical, subtly altering gravity across its surface. Rotation also helps maintain Earth's magnetic field by influencing the motion of molten iron in the core. A weaker rotation could weaken that field over time, reducing protection from solar radiation. Even our atmosphere depends on rotation to remain evenly distributed. Without it, gases would slowly migrate, thickening in some regions and thinning in others. None of these changes happen instantly, but together they show how deeply motion is woven into Earth's identity. A common assumption is that if Earth stopped spinning, everything would simply float away. That feels intuitive, but it is incorrect. Gravity does not come from rotation, it comes from Earth's mass. Even without spin, we would remain firmly attached to the surface. Another misconception is that life would end immediately. While an instant stop would be catastrophic, a gradual slowdown would give life time to respond, migrate, and adapt. The real danger would not be sudden death, but long-term instability. The absence of motion would not destroy Earth in a single moment. It would quietly make Earth less livable over time. A slower spinning Earth would offer strange benefits. Longer days could mean more time for solar energy collection. Certain regions might enjoy extended periods of mild climate near the boundary between light and dark. But these advantages would come at enormous cost. Extreme temperature differences would strain ecosystems beyond recovery. Global coordination would become harder as time itself loses uniform meaning. Entire cultures, calendars, and biological rhythms would need to be reinvented. Adaptation would favor some regions while abandoning others. Survival would depend less on technology and more on geography. The planet would not become hostile in a dramatic way, it would become selective. Earth's spin is a reminder that the most important forces shaping our lives are often the ones we never notice. We worry about storms, earthquakes, and disasters because they feel dramatic. But the quiet, continuous systems that keep the planet stable are far more important. Rotation, magnetic fields, atmospheric circulation, and orbital balance are not luxuries, they are prerequisites. This thought experiment shows how life on Earth exists not because conditions are extreme, but because they are balanced. Stability, not intensity, is what makes civilization possible. Conclusion. Earth has been spinning for over 4 billion years without pause. It does not do so for our benefit, yet everything about our existence depends on it. The next time you watch a sunrise or notice the slow movement of shadows across the ground, remember that you are standing on a planet in motion, carried through space by forces far older and larger than humanity. If this idea made you see Earth differently, consider liking the video and subscribing for more explorations like this. Share your thoughts in the comments. Would humanity adapt, or would this be the end of civilization as we know it? And if there is another what-if scenario you would like explored, suggest it below.